Hey friends, welcome back to another episode of The Real Rebuild. We're taking a look at how I built my house. You know, I completed this house, it'll be 2 years ago about the time we published this. And I'm looking at it from a perspective of what would I do differently, what's really held up. And also as we get into this episode, which is the MEPs, mechanical, electrical, and plumbing, we've had some pretty extreme weather. You know, this summer we had temps where we averaged 105, 107 most days in the summer, and like almost all of July was over 105. And so I suspect that you're going to be interested in hearing how my HVAC system fared during that time. Now we're going to talk about HVAC, we're going to talk about dehumidification, fresh air. We're going to get into low voltage. I'm not really going to spend a lot of time on my electrical, but we got a lot to talk about. With that being said, today's episode, mechanicals, let's get going. The Real Rebuild, a Build original series, is brought to you by James Hardy. This episode in particular is sponsored by Airex in Santa Fe. Let's get going. Okay guys, let's actually kick off this video with a little bit of a look back. I rewatched this video that I titled Mitsubishi HVAC at My House Full System Tour, and Kimberly Llewellyn, who's an engineer, did this video with me. I'm going to play the first part, then we're going to actually pull my HVAC plans out, but I think this will give you kind of a good intro to what we did here, so let's check this out. Funny enough, they don't even make that coffee machine anymore. It's good coffee. Today's build show coming from my house under construction. That's right, the Real Rebuild mechanical systems are in, and I got a really fun tour to show you today. We're going to be showing off my house, and we're going to be talking specifically about to-zone or not to-zone. Now, I ended up on this house with 3 separate zones, plus a party unit. Plus, I've got a garage HVAC system, so I've got a little heating and cooling from my workshop space. Really fun episode, and I have my old friend, Kimberly Llewellyn, a really smart engineer who's the rep for Mitsubishi for the high-end builders like me who do high-performance stuff. Today's build show is sponsored by Mitsubishi Electric Train US. Let's get going. Little pause here, by the way, you'll notice that we had our masks on. We filmed this right in the heat of COVID, of the battle. So I realize in today's day, it's a little weird to see us doing a masked episode, but that's what was happening during the time. All right, guys, let me introduce you to my old friend, Kimberly Llewellyn. Kimberly and I have worked together for probably 10 years now. And Kimberly used to work with Positive Energy, who did all these load calcs for me and did this full design. Now, not everybody's gonna do this level of design and this level of detail, but at a minimum, what should builders or homeowners that are thinking about designing a good system do?
So Matt, at a minimum, everybody needs to get a good quality load calculation done. That's where every good system starts.
All right, I'm gonna pause here. Did you guys ever grow up watching Mystery Science Theater 3000? That was a show when I was a kid that I loved. It was a couple robots like in their outline as if they were in a movie theater, and they watched B-rated movies and they would comment. I kind of feel like this is an episode of Mystery Science Theater 3000, but let me pause here. First off, that set of plans on the table is my full HVAC plans. I really got the full meal deal done from my friends at Positive Energy. And if you have the ability, if you have the means, if you're a custom builder watching this, you have a client that's going to build an expensive house, absolutely the way to go. They're incredible. Here they are on my computer here. You can kind of see the PDF version of these, but we're talking about mechanical plans that are 11 pages. That's more than a lot of builders get on the structurals and architecturals often. So this is an 11-page set. This is legit. This is also not inexpensive. I don't know the exact cost, but I mean, we're talking about you know, $10,000+ on a mechanical plan, probably quite a bit more than that. Of course, I got a discount because I've been friends with them for almost 20 years now. But if you can afford it, highly recommend it. But what Kimberly's saying here is, at a minimum, we should get a load calc done. And a load calc is often referred to as a manual J. Let's take a look at the manual J on this particular house. And if you want to watch the video and see Kimberly and I do it, you certainly can, but let me talk you through it. A manual J is input by an engineer into a computer, a load calc software, and I forget the two versions of it. I think one is WriteSoft and another one's Load Calc or something like that. But what they're doing is they're saying, okay, this house built in Austin, Texas, with this orientation, you know, the front door facing here, these windows facing this direction, it knows where it is. You can even input things like shading on this program. You're also going to need to know all of your values. Like before you start construction, you need to know exactly what window package you're getting, and you need to know all of your insulation values, and you have to get a pretty good gauge for what your air tightness is going to be, because they're going to input that on the computer, and the computer then is going to spit out these load calcs. Now in this section on the plans here that I'm zooming in on, which is called Basis of Design, this is where you're going to see the kind of here's what the basics of the house is. So weather station, Austin, Texas. Obviously, if you're building a house in Minneapolis, Minnesota, totally different set of weather data. So you got to put that in. You're also going to put in this outdoor design temperature. There's a little bit of flexibility here on that outdoor design temperature. But remember, if you need to turn this into a governing body like I do, I can't just put in whatever design temperature I want. For instance, I mentioned at the top of the program here, it was 105 this summer in July. Well, you're going to notice here the outdoor design temperature on this plan is for 100 degrees. And what this is saying is that at 99% of the time, it's never going to be hotter than 100. And 99% of the time, it's never going to be different than these values. It's also saying the indoor design temperature, and you can change this a little bit, but it's saying, look, in the summertime, in the wintertime, here's what the design temperatures are. In other words, this is what I'm going to heat and cool my house, because ultimately this program is going to decide how much load is on the house, how much sun, how much heat is hitting this house, and how much is the house gaining, meaning how much air conditioning do I need, and how much is the house losing heat in the wintertime, so that I need to heat the house and keep it warm for the occupants. Pretty cool program. It's also breaking down building volume here, which is going to be important for you as a builder later on when you do that blower door test. And if you own a blower door like I do, I'm using this number from the calculation that the engineer did to figure out what is my cubic volume of the house, so when I do a blower door score, I can actually make sure that my number is correct. And as you scroll down here, there's the rest of these values that are getting inputted, including what is the ventilation rate. The design ventilation rate, you can see right here, is 180 CFM. Now, again, you have a little bit of input on this as a builder, but there's some parameters that you're going to have to be limited by. And I would be cautious with tweaking these numbers. Like, for instance, I didn't say to this HVAC designer, look, I need the design temp to be 110 because I could hit 110 in Austin, Texas. If I did that, I would be skewing the numbers in a way that I don't want them to be. And what we're looking to do is say 99% of the time, my house is fitting in this envelope of design range from high to low, and from inside temperature. And so we really want that, of course, knowing that there will be some extremes. But what we're going to caution against is oversizing equipment. For years and years in the building industry, there's been rules of thumb where HVAC contractors would say, oh, you're building a 1,000 square foot house? Well, we normally put in 400 square feet to the ton, so you need a 2.5 ton air conditioning system and heat pump heating system to heat and cool this house. That is a terrible load calculation guess, and in fact, my house, you're going to see here in a minute, is somewhere around 1,000 square feet per ton of air conditioning. It's a very tight and a very well insulated house. And so now let's scroll down and let's look at the actual, this is the part that's called the manual J. And again, Kimberly and I went into this. I'll link below so you can see that video, but you saw the title of it if you want to go see it. First off, my house actually has 5 systems or 5 zones. It's a little bit of a misnomer though, because one of those zones is my garage. I put a Mitsubishi mini split 1-to-1 system in my garage, meaning one head on the wall and one outdoor unit feeding that head. And then I have a party load system. I don't know if you've seen any of the videos, but I've got one mini split head that's actually going in my hallway, or really my stairway, I should say, on the first floor. And I'm calling that a party load. Meaning, when I designed the house, I really wanted to keep my design parameters tight, but I wanted a little bit of flexibility to say, hey, what if I do have a party? What if I want a little extra load? I don't want to power my car with a V12 engine when I need a 4-cylinder most of the time. But what if I want to pile a bunch of clowns into my car and really load it down? Would be really nice occasionally to put on my other V6 engine so that combined I've got 10 cylinders of power. And that's what I think of a party load as. You know, when it's just you driving to work 90% of the time, 99% of the time, a 4-cylinder engine's all you need. But you pile a bunch of people, you get a bunch of guests over, it can be nice to have that party load system, and we're gonna talk about that in a minute. But let's look at the room calculations and air distribution requirements. So, oh, actually, let me back up a second. Let me show you my zones real fast too. If we scroll over here, you're gonna see a first floor, second floor. So here, let's look at the first floor. This is the front door. This is the garage. When you come in from my garage, you end up in this laundry room area. This is a pantry. This is the doorway into the kitchen, and this pink zone over here is the kitchen. This pink zone is one zone in my house, and you're going to see here in a minute that we're heating and cooling that with one recessed ceiling unit. That's a Mitsubishi unit that's 6,000 BTUs. I'm going to show you that in a second. And that's providing the heating and the cooling just for the pink zone of my house. I talked about my garage mini split. This is my garage zone, and so that unit is just doing this area. Now don't look too closely at placement, because I ended up moving this from this location to here on this wall. And my kitchen unit, I moved it into this hallway here rather than in that space by my island, but you get the general picture. And then the whole rest of my first floor, my foyer, my dining room, my living room over here, my media closet, and by the way, I've got a gun safe over here, my master bedroom, and this is actually my older floor plan. This is not the exact floor plan, but all of my space, that's one zone that's being conditioned by this unit, which is up in the attic. And then I mentioned my party unit. That's this guy right here. They're calling that unit 3A. And then when we go upstairs, all of my upstairs space, my kids' bedroom, is all on one zone. So that's the 5 total zones. Now let's go back here and double check which zone number is what. So kitchen is zone 1. Zone 2 is the whole rest of my first floor. So now let's use those numbers and go back here to the load calc. So zone 1, my kitchen, the area of the pink that you saw in a second ago in my kitchen, laundry room, my wife's little office area, and my pantry, that's 319 square feet. Oh, I guess they're listed right there: kitchen, pantry, laundry, mud. And the sensible gain, meaning in the summertime, how much heat is coming into that area from my windows, from my walls, from load, that sort of thing, is 3,800. The latent gain, latent and sensible, the difference is sensible is kind of like the, I think it's called the dry bulb temperature, meaning like when you just read the thermostat, what's the temperature? That's the sensible gain. Latent gain is the additional heat load from water vapor that's trapped in the air. We're getting a little nerdy here. But ultimately, when you run your air conditioner, there's 2 types of heat that it's taking out. It's dripping water out, and it's condensing water on that cold coil. That's taking the latent heat out. And then the sensible heat is that kind of air temperature. This is all in layman's terms here. So the net gain for that area is just shy of 5,000 BTUs. You're also going to notice that there's a ventilation gain as well. This manual J is taking into account, you saw earlier, I have 180 total CFM of ventilation. Now, I do have a very efficient Zender energy recovery ventilator, which is going to drop a little bit of the moisture coming in on humid days. And it's also going to temper the temperature on cold and hot days. But either way, it is adding load. Ventilation does add load. And so all combined, my kitchen space is about 5,800 BTUs of net gain, quite a bit less in loss, like, you know, what is that, 2,800 and 1,000, so 3,800 loss in the wintertime. That's how much heat we got to put back in the space. So in other words, in the kitchen area, in that pink zone, I really don't have that much load. That's about a half ton. That's 6,000 BTU. Remember, 1 ton is 12,000 BTUs. So that entire space, I've got just one recessed Mitsubishi mini split that does both heating and cooling. It's a heat pump. And then that unit is tied to an outdoor unit that's what they refer to as a multi-split. Okay, y'all, 2 years after I moved in, I remulched on this side of the house. But other than that, really what you're seeing here is as is. I really didn't clean up my equipment. Let me run through a couple things and tell you a couple things that I was surprised by. And I'm gonna start actually kind of working my way down. So first off, I used some Arlington inboxes on the house. These are a box that's recessed into that kind of deep cavity that I've got because of insulation. But here's one surprise. Notice the door is yellowing, but the body of the box is not. I don't know what the deal is. There must be a different type of plastic. I didn't paint these knowing that I had white hardy siding. So it looks like I'm gonna have to paint this cover because it's 2 years later looking pretty yellow, and this is kind of a shady side of the house. However, my stainless flashings, the Versatech PVC that I use, still looking money. I probably need to wash down my siding just because of all the landscaping that I've done, but this is still the original hardy looking great. I'll talk about that later. Aqua hose bibs, I've got these around the house. I also, inside my closet behind where this is, put an access panel. So if I ever need to change that hose bib, which I probably will in 2 or 3 decades, I've got easy access, no drywall cutting. That was a big deal for me. Anywhere I've got a hose bib on the outside, I've got an access panel inside. And then over here, this is my disconnect for my 4-ton Pumi. So this is a Mitsubishi multi-split. You've probably heard us talk about on the build show before VRF systems, variable refrigerant flow. What this means is that this outdoor unit, even though it's a 4-ton unit, it has kind of like an analogy of a gas pedal for a car. We can ramp this unit up or down. So it's 4 tons if it was at full-on speed. If I got the gas pedal all the way down, boom, I can get 4 tons of heating or cooling heat pump out of this. But what's cool about Mitsubishi's VRF technology is it's a variable speed. And I don't remember the exact percentage, but I think it can go down to around 15%, all the way up to 100%. So on a day like today that's real mild, I don't need a lot of heat out of my heat pump. It's probably barely running. In fact, you can see the fans are kind of barely spinning today. It's not putting a lot of heat into the house. And I mentioned earlier it's a multi-split. That means that this outdoor unit is actually tied to 4 indoor units on my house. My recessed ceiling cassette on my kitchen is tied to this. My main unit, which powers my main floor, which is a medium static or low static pressure ducted system, is tied to this. I also have a stairwell unit that I call my party unit. I take that back. I said 4 heads. There's only 3 that are connected to this, pardon me. And that unit I only use when I need extra heating or extra cooling capacity. You know, when it was 105 out this summer, I did kick on that party unit to get some extra cooling capacity, because I found that if I left my thermostat at 75, let's say, when I left for work, if someone tried to kick that down, it probably would catch up eventually, but not by the time I went to bed at, let's say, 9:30, because it was 105 out that day. And in Texas, it's often in the 80s, even at the dead of night, in the middle of the night. So we've got some really high temps. And in Austin in particular, our design temperature for our manual J is 99 degrees. That's mandated by the city of Austin when you size your loads. So having that extra party capacity was really nice for me this summer. And then check this out. This is my Airex Titan outlet. I can't remember the name. I think this might be the TSS model. They have several different models. This is the smaller unit, which you can see the pipe that comes out, the Freon line, totally protected by this PVC here. So in other words, all the pipe insulation is covered by their PVC, which means no degradation. Now this is a little, my white PVC is a little dirty after being out in the rain for 2 years. But other than that, no degradation, looks fantastic. I can feel my insulation in there still in perfect shape. Stainless steel hose clamp looks awesome. I also use the same mounting blocks I did everywhere else. So this is that same Versatech. It's 1.5" material, so it's pretty thick material. But again, I didn't paint that. I also did face screws on all my mounting blocks. And I like how this TSS also has face screws. So if I ever need to change this, which you're going to someday, it's just a matter of time, I can get there. And then you know, because I like belt and suspenders, and also I want to do, you know, some elastic waistbands and maybe also hold my pants up, I put some big stainless flashings on, which, did I need those? Maybe not, but they sure are nice, and they actually look really pretty too. My next unit over here is another Mitsubishi, but this is a smaller unit. This is in 1.5 tons, so 18,000 BTUs, and this is what they call a one-to-one unit. So my upstairs kids space, which is mounted in my beautiful attic, is tied just to this machine here. And again, this is heating or cooling outside. I've got another Titan outlet to that. And then beyond me, it's a little tight in here with my shed that I built, but I've got my sand CO2 split heat pump water heater. Kind of a unique system. It's one of the only ones I know of in the market that has an outdoor unit that makes the hot water from ambient temperature, which makes a lot of sense in the South. And then there's a set of Uponor pipes that come out of the building, 2 of them. And that's where I used another type of Airex boot. Those happen to be the TGS Airex boots. So each one of those is holding one water line in and out. And again, I wrap those in pipe insulation. Now I did put heat tape in there though, just to be safe. My buddy Jake Bruton taught me that lesson because he built with the same system 2 years or so before I built this house. So the one outlet you see plugged in here is actually my heat tape. It's wintertime now. It doesn't very often get below freezing, but we had some 17-degree days, or nights I should say, last winter. I had no problems. That system's working great, super easy. And of course my Aqua hose bibs shut off back into my wall cavity, so they're shutting off into the warm part of the house. It's been great. I mean, the outside of the house looks awesome. Hey, 2 other quick things before I leave the side of the house. See the big boot, the air inlet boot up there? That's a Seiho grill cover. I actually got that custom colored, which is really cool. I've seen those a lot in silver, which is the basic color, but you can custom order those in a specific color, and it matched this beautiful hardy white that I've got on the outside of my house really nicely. So that's my makeup air inlet, which is part of my Fantech makeup air system, just for my kitchen exhaust. And then see the copper pipe that's sticking out of there? That's a condensate overflow drain. So if for some reason my condensate line were to clog up and the air conditioner wouldn't take the water, the condensate down the drain automatically, it would overflow into the pan, and that pan is connected to that pipe with a P-trap. So it's placed specifically over that window. So if you do see water coming out of there, you know, oh, wait a minute, why is there water coming on this window? None of the other windows have water. I got to check it, and that's what it's going to be. You're going to find that that drain pan has overflowed. So it's good to put that in a spot that you're going to notice it. And on the side of the house, the best place to do it, where we're not over here very often, is on top of a window. Hey y'all, at my house, I've got a old product that now there's a new product version of. These are the Airex Titan Outlets. This happens to be the TGS model that I used, intended for a siding install. But you know what? They make this now in a 2-piece retrofit. It's the TRS model. I mentioned this in a video a couple months ago, and I probably mentioned it too early. They didn't have stock everywhere. They've been making these things on 2 shifts. They're made in California, family-owned company. They make a lot of cool products. I used the TRS, or pardon me, the TGS here, but had this been a remodel, the pipes are already in place, they were connected. I could have retrofitted this now with a TRS, so that's a really cool new product from Airex. Okay, so let's keep moving. A couple things I want to mention. My house, 2 years later, incredibly comfortable. Probably slightly disappointing, honestly, in my energy efficiency, though. And I think I fall into the trap of a lot of builders, or frankly, a lot of customers thinking, I'm building a really high-performance house. My energy bills are going to be super low. They have been to some degree. You know, I lived in a pretty inefficient 2,000 square foot house prior to this house. But what I didn't have in my old house was a heated tile floor, a tile warmer. I have 2 spaces now for TVs rather than 1 at my old house. I have I have an 800 extra square feet in this house. I also have now teenagers that all have phones and chargers and phantom loads. I have 2 ovens where I had only 1 oven before. This is a 100% electric house rather than a partial gas and electric before. Long story short, my energy bills really haven't been much lower, although they have been a little lower than my old house, and I'm almost 50% larger in this house than my old house. But it's not like I'm getting $50 electric bills, and at this point I have no solar I've been wanting to add some solar at some point. Haven't done that yet. I hope I will do that at one point. But the thing that has made a difference on my house, and if you're a builder watching this, or if you're a homeowner thinking about building on watching this, the difference for me is comfort, comfort, comfort. My house, even when it was 105 out in July, crazy comfortable. I loved it. My house coasted along at 70 degrees on my thermostat, even when it was 105 outside. I will tell you though, there were a couple days when we came in and out of the doors more, and that's a big part of my load or my gain is opening the doors and the kids letting the dog out and leaving the door open. So I did use the party unit a couple of times to cool down the house, and I was thankful I had that. But funny enough, I almost never used that party unit in the summertime. Where I've ended up using it more, funny enough, is the winter time, and I've done it as a zoning. This is a little bit of a diatribe here, but if you look at this diagram, you come into my master bedroom here, and I changed this layout just a little bit, so it's not totally correct, but basically my thermostat is on the wall right after you walk into my master bedroom. And there's a return on the ceiling right outside my master, so air is going to be traveling by that return. There's also not a place that it's going to get into direct sunlight. You always want to make sure you put a return, or pardon me, you always want to make sure you put a thermostat on a wall that is not getting sunlight through a window that would give it a false reading. But you know what? I like sleeping colder at night. And in the winter, my wife likes the house a little warmer. But my bedroom, because it's so efficient and because I've got such great insulation on these walls, doesn't really change temperature much. And even on a very cold night, it takes a long time to cool off. So as a result, what I ended up doing was leaving the thermostat, which is here, set at a lower number, set it like, what did we have it set at most of the winter time? Let's say 66. So my bedroom was slightly colder, and I was okay with that. But my wife in this kitchen living room area liked it a little bit warmer. So I set this unit in the kitchen at more like 70, let's say, or 71. And I set the party unit at 70 or 71. So that this whole space out here was more like 70, 71, 72 degrees. And my master was in the upper 60s, which is where I wanted to sleep at night, or maybe even the mid 60s through the winter time. And so my point here is when you spend time zoning, thinking about zoning, buying really efficient and excellent equipment from a company like Mitsubishi, you get the ability to really dial it in. I think America has been fooled into thinking that we can precisely control things like we supposedly can in our car. You know, even my Chevy truck, which is a pretty base model truck, has dual climate zone, right? I have cloth seats and a bench in the front, but I've got dual climate temperatures. Do you really think that if my wife sets her climate zone at 75 and I set mine at 65, do you really think that I'm really 65 degrees on my side of the bench seat and she's 2 feet from me at 10 degrees warmer? Of course not. That's totally bogus. But those numbers on the wall make us think that. I think that's happened over the years with people in their HVAC systems, and there's all kinds of zone damper systems out there and all kinds of things you can do. But the ultimate control in my mind is having a fan in a separate unit for each zone that you want zoned in your house. And if I could give you one piece of advice that's kind of a generic piece of advice all the way around, would be if you're building a 2-story house, please get a HVAC system for your first floor and a second separate system, separate zone, not zone dampered, for your second floor. In my case, I really have 4 zones inside my house, 3 zones plus that party unit. It's been unbelievable. I've absolutely loved it. It's worked flawlessly. It's kept me nice and cool even when it was 105 out. It's kept me nice and warm when we had some teen temperatures in Austin. So with that being said, check out that video if you want to see more. And hopefully we showed you enough kind of general B-roll of the zones and you can see what that looked like. Let me move on. The other thing that I did in my house that I think is becoming more standard, especially in the South, but I'm starting to see it more and more in the North, is I did separate dehumidification.
You know, a wise man once told me, if you have a 2-story house, put a unit upstairs and a unit downstairs. The same is true for dehumidifiers. Big fan of dehumidifiers if you're in the South, but they can be really comfortable in a lot of places. And in my house, the Santa Fe dehums, absolute must. You've got to have it. When you have a really airtight house, a really high performance house, the AC is hardly going to run, especially on the shoulder season. Like today, it's 55 degrees out. My heat is not on. So my dehumidifier is working a little bit. You can actually, I don't know if you can hear it, but this unit's pretty quiet. It's running right now and it's dehumidifying. The other thing that I'm doing is I've got one up and one down. Now I did my install in this house a little bit different. You know, a lot of people like to put the dehumidifier into the duct system and have it distributed. I actually like to do it separately. And so at my house, what I did was this Santa Fe has a return from the hallway, and then it dumps the supply into 2 places, my 2 upstairs kids' bathrooms. So I've got slightly hotter air coming out of those supplies, but it's also really dry air, which means that those bathrooms for both my daughter's bath and my boy's bathroom, they dry out really, really quickly. On the other hand, I have heard, my buddy Sean Harris says that it's a good idea to dump these into the duct system, because if there was any residual moisture or condensation happening, that would help dry that out and make sure that that's a really mold-free, good install. So I see it both ways, but I really like knowing that this system is on by feeling an outlet that has slightly hotter, dry, dehumidified air coming out. That being said, downstairs, my other unit, this is a 70H, which is pretty much the smallest unit that Santa Fe makes. My downstairs unit is slightly bigger. It's a 98H, and that unit is dumping into my duct system. So it's actually kind of distributing throughout my first floor. As I've been in this house 2 years, one thing that I want to point out is I like having a little bit of extra capacity. You know, when this system was originally designed, Positive Energy told me to put a 70H downstairs and a 70H upstairs. But I've got a big house, I've got a busy house, I've got teens that shower way too long, and don't forget, I've got 24/7 fresh air out of my Zender system. And that Zender is definitely moving moisture from the air streams. It's a balanced system, meaning is it's putting 100 CFM into the house. It's exhausting 100 CFM, but it's very humid outside in Austin, Texas, a lot of the year. And as a result, that fresh air could actually raise the humidity in my house. So these dehums are not just handling the capacity of my house, the people breathing, my 7 total bodies in the house, including my black Labrador, but it's also handling the additional load of my fresh air system. So I like having a little bit more capacity. I think that's something that I've kind of learned after being in here 2 years. We want a dehume up and a dehume down, but when they specify this unit works up to so many square feet on the website, I can't remember what the 70H says. It probably says it's good for a 2,500 square foot house. Remember, those are just rules of thumb. And when it comes to your actual house and your actual location, your humidity, the people that are in your house, you're better off with a slightly bigger unit. The last thing I want to mention on that is this unit does run a fair amount because it's a smaller unit, and I suspect my kids are taking 45-minute showers as teenagers. So it's working hard. Had I had a slightly bigger unit in here, the duty cycle would be less, which means that it would probably last longer. I suspect that this one might go out prematurely compared to a slightly bigger unit that had to run less. So I do like that bigger 98H downstairs. With that being said, Santa Fe, great partner of the Build Show for a long, long time. And I highly recommend their entire line. Now, if you're looking for fresh air and you don't think you have the ERV in your budget, several of these models you can bring fresh air in through the dehumidifier. Certainly better to have an ERV, but that's not a bad way to go if you're starting on fresh air and you haven't done that before. But long story short, Santa Fe, great company.
Okay, we talked HVAC plus D. Gosh, long episode, guys. This is one of my favorite topics, so it's hard for me to condense this. Next, let's spend a brief amount of time on fresh air. If you want to watch the entire video, this one's called Passive House Fresh Air System Install and Cost, Zender. I want to show you a quick snippet over here.
The mechanicals are going in, that's HVAC. When we think about HVAC, we typically are just thinking the heating and cooling for the house, but the V is critical, that's your ventilation. And most builders, most houses under construction, the ventilation is just an afterthought. That's your dryer exhaust. That's your exhaust fans out of bathrooms. Maybe there's a fresh air input to the furnace or through the dehumidifier. But on the build show today, I'm going to show you a system that's like no other. It's a really good system. And let's talk about why we need that. When we build a really tight envelope like I have here, we're not having air infiltrate in when the wind blows or when an exhaust fan turns on, let's say. The house is going to be really, really airtight. So as a result, we need a fresh air input. And I would say whether you're building a house to this crazy tight standard or you're building a more modern house to, let's say, just code built standards, you probably need a fresh air system, and you probably need a really good one, because we don't want to rely on fresh air just when the wind is blowing, right? Or when your furnace kicks on. We want that fresh air all the time. Now, specifically, we're installing a Zehnder ERV in this house. And if you're in the north, you've probably heard of HRVs, that's heat recovery ventilators. This is basically the same thing, except it's not just going to recover the heat out of the fresh air, it's also going to recover energy or enthalpy, moisture basically. Now, this is my first floor, mainly public spaces here, but my master is back there. Let's actually go up to the second floor. In the attic is where this unit's being installed. I'll meet you up there. But here's the unit, and here's Chris from Zehnder right here. Hey Chris, how's it going,
Matt?
How's the unit looking, man?
It's looking good. A few things with the Zehnder system. First of all, this is the Zehnder ComfoAir Q600 ERV. Basically what we're doing with this is we're changing the air throughout the house. We're going to do that on a continuous basis. And what makes it the best? First and foremost is going to be the performance of the unit itself. And I'll break that down and show you a couple things. But what you're trying to do is you're trying to ventilate. You're trying to control that ventilation. Mm-hmm. You want to do it with energy recovery so that you're not, otherwise just leave the windows open.
All right, so if we're in the north, we're worried about just an HRV, a heat recovery.
Sure. Yeah.
Because generally in really cold climates, it's low moisture outside. But here in the south, in the southern U.S., often it's really humid out. And if we bring that fresh air in, there's a big penalty because now we've got all this humidity to deal with.
Right.
And all of a sudden, if I'm ventilating correctly, my house humidity could go way up.
Right.
And I've lost that comfortable feeling.
Right, yeah. So an ERV is going to allow you to transfer moisture between the two air streams.
And how efficient is this in both heating recovery and moisture recovery?
Right. With an ERV, you're going to have a slightly less sensible or heating recovery than you do with an HRV.
Okay.
But still, you're going to be with this unit around 85% heat recovery.
That's amazing.
That's 85% of the difference in temperature between outdoors and indoors.
Gotcha. So it's a 50-degree delta, which would be unusual for me.
Yeah.
But a 50-degree delta,
Yep.
85% of that
That's
temperature
right.
I'm going to be able to recover
45
back.
degrees of it or so, somewhere in that range.
Okay.
And then on the humidity side, we're going to recover about 2/3 of the difference between outdoor and indoor humidity. The Q600 is a really smart ERV. Mm-hmm. So the controls are basically, this is a self-balancing unit. So the controls are constantly monitoring the air temperature.
How efficient are those motors too?
Yeah, the motors are super efficient. What we're looking for is, basically less than 3/4 of a watt per CFM. So that's a pretty good standard, and the Q600 meets it easily.
So this unit we've kind of engineered. By the way, Positive Energy helped me with the design, but you guys do that as well.
Yeah.
We engineered the system at my house for my conditions, my number of people in the house, to run at 180 CFM. That means we're sucking in 180 CFM and we're pushing out 180 at the same time.
So what you'll see on the top of the unit here is we have 4 duct connections. And as you said, these 2 are connected to the exterior of the house. This is your exhaust, this is your intake. Over here, we've got the return coming back.
Okay, so we're seeing arrows in.
That's right.
Going back into the unit from the house.
Yep, and here's your supply, so it's coming out. Basically have 2 air streams that are being directed through this heat exchanger core, or in your case, an enthalpy exchanger.
Yep.
This core, especially, that gives you that surface area for that transfer. This is called a plate exchanger, and the reason it's called that is because what you've got is a series of plates in this basic shape that are stacked together. These plates are formed in such a way that they create channels. So here in your case, we're going to be pulling return air from your house, mainly your bathrooms and kitchen.
Yep.
Will come through here, and it will get directed into this side of the core. Your outdoor air will be coming in around the attic through that back port there, and it will be directed into this side. And so what we've got is air that's going to get organized. And if you think of this center rectangular section of this hex shape as the heat exchange section, it gets organized, and then we have counterflow happening.
Wow.
So you've got one airstream on one side of each plate, the other airstream on the opposite side of the plate.
And there's a lot of technology in these cores, guys. When I was doing my research, long before I decided on using Zender at my house, I was getting into the nerdiness of version 1, 2, 3, and 4 of these plates, and there's still ones on the market that are more version 1 and 2.
Yep.
This is really the latest and best technology. Which has the most amount of surface area, so that we're really exchanging that heat from one to the other. That's how we're getting that like 85–90% efficiency. That's crazy numbers.
All right, if I could summarize the Zender system, gosh, great long video. Watch the whole thing if you have time. But I think two things I want to say in summary. This is the only fresh air system that I know of that has a entirely separate ducting system and reduces the fresh air system, both the input and the exhaust, down to just 2 wall penetrations. I have an 8-inch inlet to my Zender on my north side of the house, the kind of cold side of the house, and I have an 8-inch outlet on the south side of the house. Other than that, the entire system has its own little ductwork, those shop vac tubes that you saw me installing. Absolutely fantastic system. Could totally be a do-it-yourself system if you wanted to, if you had the inclination. But in general, the absolute best in the world. Also, you pay for it. Because in the past, as builders, we've budgeted so little, if anything, for fresh air that the price of a Zender seems outrageous. I can't believe we would spend this. And yet, when it comes to actually living in a house with a fresh air system, total game changer. My house is crazy comfortable, always seems fresh, never feels stale, totally worth it. Let's move on to plumbing. Giant topic, hard to spend as much time as I want to on plumbing, but
all the other
this
flavors.
video boils it down a little bit.
We're going to review 3 reasons why I think Uponor is the winner, and actually why I've used it to
Let's
plumb
jump in
my
on
personal
Clint
house.
here doing
Now,
an
I'm
install
no
at my
plumber,
house.
but in my 25 years of home building, I put a lot of plumbing systems in, and I've spent a lot of time thinking about this. So I've got 3 reasons for you today why I think Uponor is the winner. Today's video is sponsored by Uponor. Let's get going. All right, guys, so we're talking PEX specifically today. I've put a lot of PEX in my houses, and in fact, probably in the last 20 plus years, I've used PEX almost exclusively on my houses. Now, first off, there's 3 things that are different about these, and 3 reasons why I think specifically Uponor, which is my 3/4 red right here, is a little better than the PEX B flavors out there. And the first thing is flexibility. That means there's going to be a little less labor on the job. You know, if I can think about a long run where I can snake a pipe and get it all the way through there in one long run, that means I've got less fittings, and each time I put a fitting in, that's real dollars. These fittings are not inexpensive. A lot cheaper to run straight pipe and not put fittings on it. Plus, every time I got to put a fitting on, I'm taking a break, I'm cutting pipe, I'm using these crimpers. All these things take time and take money. So if I can snake that flexible Uponor pipe through there and not have fittings, I think it's a total win-win. Okay, next up, freeze protection. It's not totally freeze-proof, but PEX A, Uponor PEX, definitely has the ability to expand and contract because that pipe is flexible. And so this can be much more freeze-resistant than most other flavors out there, including PEX B. Now, I did a bunch of videos about this in the past. Go check those out, where I put sections of pipe in the freezer. I was never once able to cause a leak in the Uponor because of that expansion ability. So I think that it's not 100%. You definitely still want to protect it. You want to use frost-proof hose bibs. You want to put insulation on it. But if there's going to be an issue that's unforeseen, you're going to be in much better shape with Uponor than all the other flavors out there. And number 3, this is the big one, fittings. Let's talk about this for a minute. So when you make a fitting with Uponor, you've got an expansion collar, and that expansion collar is going to slip over the end of the pipe, and there's some nubs on the end which stop it. Once you do that, then you're going to grab your fitting, and let's use this, actually I'll put it on the other side of this one since I've already got one here. You're going to notice in this fitting there's some wings that stick out. Eventually this is going to fit into here as deep as the wings. But here's what I like about this system. This is an expansion fitting. Let me show you how to do it with my little Milwaukee tool here. All I'm doing is throwing in the pipe and making sure that those wings are sunk all the way in. And it's probably hard to see there, but it's just slowly kind of contracting back to its original size.
Okay, let's jump in on this video, which now let's talk about, we've already said why I like Uponor and the benefits of the system. Let's talk about system design, which by the way, I'm not pulling it up here, but I got Uponor to do a full system design for my house, which you can as well. There should be a link in the description to get to that. They have a site that allows you to upload plans, and I believe there is a small charge for that. It's not much, but totally worth it to get them to size your system and do a layout. They have this Uponor Logic system. But I've spent a lot of time over the years with a guy named Gary Klein, who's probably the foremost expert in piping systems. You should just Google his name and read anything that Gary's written about plumbing systems. But Gary has this theory that we should be able to plumb a house and install a water heater centrally located, which by the way I did in my house based on Gary's advice, so that when we open a tap on any fixture in our house anywhere, we should be able to get hot water there without wasting more than 2 cups of water. I did a little demonstration in this video, and I'm actually going to kind of voice over it, but I took 2 10-foot sections of pipe. I took a 10-foot long piece of 3/4 PEX and a 10-foot long 1/2-inch PEX, and we filled it up. Andrew, who used to work for me, is up on the roof there, filling it up with just some dark colored water so we could see how much water is actually in a 10-foot section of pipe. I'm going to fast forward here a little bit to the results, but basically what you're going to find out is that a 3/4-inch pipe holds double the amount of water in the pipe in a 10-foot section, which means that if you plumb your house with 3/4 lines everywhere, you're going to have to move twice as much water through, and especially thinking about hot water, to dump down the drain before you get hot water delivery. So what we need to be really cautious on is making a trunk and branch system that requires the smallest pipe size that we can use to get the volume out of the fixture. So in other words, I did a trunk and branch line at my house where the main trunk through the house is a 3/4 line, but then my branches, or maybe twigs, depending on how you look at it, are all 1/2-inch PEX. To be honest, if it was code approved, I would have gone 3/8 PEX at almost every location. With today's low flow fixtures, you don't necessarily need 1/2-inch, even on showers and other higher volume devices, to get that amount of flow through them. But centrally locating your water heater is key, because now my centrally located water heater means that my master is right behind that water location. And so my shower, my 2 vanity sinks, I turn that hot water on in my house and I'm dumping like maybe 1 cup of water down the drain before I've got hot there, maybe 1.5 cups. It's crazy. Now in the rest of my house, I have a hot water loop, and I don't have a continuous recirc. I have what's called an instantaneous recirc. Metland makes them. It's their demand system. I'm sure there's several others out there in the marketplace. I've really had great success with Metland Demand. It's basically a taco pump, or taco, however you pronounce it, with a signal to each one of my bathrooms and a low voltage switch that's labeled for me hot water. So for instance, in my boys' bathroom upstairs, which is actually the furthest piped fixture from my water heater, all my boys have to do is toggle that switch. It goes green for a second and lets them know, okay, the pump is working. The pump will circulate that line, and what happens is when the water gets back to where that pump is, there's a sensor on the pump, a little thermocouple, and that sensor says, oh, the water's hot now, I can turn it off. And so it's not a continuous, oh, the pump's running for 2 hours. It only circs it until it's hot. So then when my boys turn on the hot water, or my daughter in her bathroom turns on the shower, let's say, they're only dumping maybe a cup and a half down the drain, which means everywhere in my house, when I turn on hot water, I'm getting it pretty darn fast. Not instant. Don't use that term with your clients. This isn't instant hot water, but I'm getting very quick water delivery, and I'm not dumping a bunch of cold water down the drain until it gets hot. My old house across the street, where my master was the furthest fixture from my Renai, way on the other side of the house, I had to dump, I don't know, at least a gallon or probably 2 gallons down the drain before it got hot. My wife would turn the shower on, go in the bedroom and do something or fold some laundry for a minute, and then jump in the shower because she knew it took so long. And then often I'd be bothered because she was wasting hot water at that point. But she was like, well, it takes 2 minutes to get hot. What am I going to do? Sit there while I'm naked waiting for the hot water to get hot? Of course. So on that house, I retrofitted a Metlin demand system, and it was a total game changer. On my new house, I designed with that Upener logic system in mind, kind of using those same principles that I've been taught from Gary Klein, and amazing super fast delivery. I would be remiss if I didn't jump into another super important part of plumbing, which is, how would I call this? Mistake proofing, maybe, is the best term. And I spent a long time on this video talking about it. But what I did in my house was I put a overflow drain, an emergency drain, in almost every location where there's water in my house. And then I made the accommodations needed to make that work. Now in this video, it's really hard to see in the foreground here, but underneath my wall-hung toilet where my boys' bathroom is, I put a floor drain in that section so that if the toilet overflowed, their sink overflowed, the bath overflowed, it would go down that drain. I did the same thing at my upstairs laundry room and in my daughter's bathroom. And at each one of those locations, by the way, I also put a marble threshold in on the outs, basically between the tile area of the bathroom and the hardwood area of the hallway, or the tiled area underneath my washer and dryer and the hardwood of the hallway, so that if there was an overflow, I'd have some type of a lip. I also spent a fair amount of time thinking about that in other locations. For instance, underneath my water heater in my hallway, which is downstairs, I was worried, what's going to happen if I have an overflow there? So I actually made a custom Schluter tiled pan, like a mini shower pan, basically, in that area. Now my inspector caught me though. He said, I know you're going to fill those with mineral oil, Matt. By the way, if you're not familiar with mineral oil, it's a way to ensure that the trap doesn't dry. Here's an image of a P-trap. This happens to be a cast iron P-trap, but they make them in plastic as well. And that P-trap fills with water so that the sewer gases don't back up and come out of your drain, right? Your shower drain would be really stinky if it didn't have a P-trap. It'd be connected to the sewer system. You'd smell like poop in your shower. So that P-trap holds water in there in a level fashion, and now that water that's level there ensures that the drain can keep those odors out. But in order to keep that drain always wet, if it's not an active drain, like a floor drain for instance, my inspector in my area required that I do a trap primer. A trap primer could be a multiple things, but when I think of trap primer in the commercial world, it's some type of mechanical device connected to your plumbing that basically gurgles out a little bit of water on occasion to make sure that trap never dries out. However, my plumber came up with an even better idea, which I liked, which is this right here. This is a trap that has an inlet on it, which connects to a UPVC, which connects to a PEX fitting. You're seeing that on that left-hand side there. So now underneath my drain, I've got a trap that has a PEX fitting. Now that PEX fitting is connected to another trap underneath my sink, which I'm using all the time, which now dumps a little bit of water into there. So The trap which is underneath my, what am I trying to say? The trap which is underneath my water heater closet, the trap which is underneath my kids' bathroom floors, and my laundry, they all have a trap primer that is gurgling just a little bit of water every time I brush my teeth, every time I run the water in my sink, all those locations. So now those locations are kept nice and dry. This is my water heater closet you're seeing on the video right here. That's where my eventual water closet will go, and I just built basically a mini shower pan and tiled it in that space. Had it been a more normal space, I could have maybe got an off-the-shelf fiberglass pan, let's say, but it was a pretty tight space. It was pretty custom. I also wanted it to look nice, frankly, so I probably went a little bit over the top on here. I probably went a little over the top on several things, actually. But I've seen way too much water damage, and at the beginning of this video, I said some stat like every year we spend as Americans $14 billion on water issues in our houses, you know, things that have happened with water. And I didn't want that to happen. So you could watch this video and see how I did that Schluter pan. But the other thing that I think might be worth watching, and I think I got into this video, let's look, is my dishwasher pan. No, I didn't get into it in this video. It must be another one. I'll have to look for that. But I put a stainless steel pan underneath my dishwasher, drain that to the outside, and I put a stainless steel pan underneath my washing machine and drain that to the outside. The only pan that doesn't have a drain, though, is where my refrig is. Underneath my Miele refrig and freezer, I did a pan, but it simply would dump water forward of the equipment so that I would see it, and it doesn't have an actual drain. In hindsight, I should have probably put a drain in, but that was one of those like, oh, I'm spending all this money putting these others in. My budget felt tight. I did it everywhere except for that spot, and I figured, well, this is probably the least likely to have a problem. I've never had a refrig leak, whereas at my old house I had my washer and dryer overflowed twice on me, and I've had several clients over the years that have had dishwashers explode on them in some way, shape, or form. So I felt like those were the ways to go. And I also had, not one of my houses, but one of my really good builder friends had a house that had just been completed by 2 or 3 months, and it was a second home for our clients in a mountain area, and they had a leak in their master floor, basically, and I can't remember exactly what happened, but it was like a supply line to a toilet. And when they came back to this mountain house, it had been raining in the house from this mild leak for literally weeks before they realized it, and the house was basically a total gut job. And here it was a brand new construction house, and had they had a floor drain, it would have totally done it. Now this builder got the chance to rebuild the house, and the client specifically asked for floor drains everywhere, which to me just made total sense. You know, why not spend a couple $100 on each one of those right out of the gates to know that I could possibly avert a $10, $20, $50, $100,000 bill later by spending a few $100 or a few $1,000 in the end. That felt like really good insurance to me. Okay, next up, low voltage. I know I'm kind of quickly going through mechanicals here just because I know this is a longer episode, and again, you could go back and watch the full versions of these. But when it came to low voltage in my house, I was looking to do an economical system that I might be able to install myself, although I ended up not doing it myself, even though I thought I would. And I wanted a system that I felt like wasn't going to be tied to a $20 a month bill to Ring or to Google or somebody like that. So you'll see that in this video, I put Sonos everywhere in my house for whole house audio, which has been rock solid, and I've had no problems with the Sonos system, my Sonos amps, my whole house audio. Anybody who comes over who's on my network can play audio on my system. It's freaking fantastic. I also did a Ubiquiti Networks camera system in my house, which in the end has been kind of, I like it. I don't love it. I've honestly had some problems with my doorbell camera. I've never once had to pay a bill though, which is kind of nice. But at the same time, my doorbell camera, seems to cut out on me more than I'd like, and I'm not quite sure what's happening on that. I probably need to get some tech help at some point. And one thing, though, that I think would be kind of fun would be to take a second to talk about my Voltec system on my house. So let's check in on this video where I talk about Voltec.
All right, I said earlier when I published my high voltage, my electrical video, I wired my whole house in 12-2 so that I could do 20 amp circuits. But you know, several of you commented, which really made me think, when I'm doing LED lighting, why do I need that fat 12-2 piece of copper in there? And it's interesting, you know, right after that, I found a company based here out of Austin called Voltec, and they make a product that's a little different than this, but I've done these a lot in the past. This is I think Leviton makes this. There's probably some other manufacturers. This is a regular 110 outlet that also has some version of USB. This happens to be USB-C at my house. Currently, I have several of these with USB-As, and these are great for charging your GoPro or your phone, that sort of thing. But anywhere else you don't have one of these, you're going to use a small brick for your phone. Now, when it comes time to plug in your laptop, though, you typically need one of these big bricks. If you were to plug your laptop into this, there wouldn't be enough juice to plug it in. That's why you got it. Even with this, you still need to use your big brick. Now, check this out. This company based out of Austin has a solution that I thought was really cool. This is called Voltex, and this is a low voltage wired and powered USB outlet. They currently make them in a dual USB where you've got a USB-A and a USB-C. And everywhere you have one of these, believe it or not, you have enough juice not just to charge your phone, which certainly you could, but you even have enough juice if you plug your laptop in here to eliminate the brick, because this has enough power to supply it to your laptop. Now here's how the system works. They make this unit here, which is the power conversion. This is this demo model right here is just plugged into an outlet, so it's getting 110 power. It's then converting that into DC, direct current. And then in the back of this, you're gonna see that it's got a bunch of these plugs. This one is this one has the capacity to do 12 of these outlets. Now we actually plug this one in to show you, check this out, that now with just a USB-C to USB-C, my MacBook Pro, this is actually Alex's on my team, that he does a lot of editing on, and this is the big one. Look, it's charging this laptop straight off here. So now I could put these on my desktop, I can put these on the side of my master bed. All those places I wouldn't need a brick. I can plug in enough juice to even power a laptop with either a USB-C or a USB-A outlet. I thought that was kind of a cool system. The other cool thing is this is rack mounted, so this will fit in my low voltage rack, and I can have my UPS, my power supply, battery backup attached to this, so that I could potentially run a couple hours, or even if I had a really big one, maybe even longer, maybe even into days if I had a really big battery attached to this. I think that brings a measure of resilience, which is kind of cool. But I also honestly just like the convenience of these. So this 12 unit model, I'm putting an outlet here in my kitchen. I'm putting 2 of them at my wife's desk. I'm doing 2 at my kid's desk. I'm doing 3 or 4 at my desk, and I'm putting 2 on either side of my bedroom table. And those outlets I'm gonna put a little higher so that I could just pull my vanity back, not my vanity, my side table rather, and plug in my phone and my laptop on the side of the bed. Kind of a cool system. This whole thing you could wire yourself with all the parts. We're talking about $1,000 or so for all this. And the cool thing is this wire is a thin gauge wire. This is a low voltage wire. Pretty inexpensive. You know, this is probably pennies per foot compared to that copper wire that I used for my high voltage, which is very expensive. Now these guys are coming out with a capacity to do 6 of these and an even smaller power supply, so stay tuned for that, but I'll put a link in the description for them. In full disclosure, I thought the system was so cool I wanted to put in my house. They gave me these materials to do for my house, which I thought was pretty cool.
All right, so that's it for electrical, both low volt and high volt. I really didn't spend a ton of time talking about high volt. Maybe we can do that a little bit in a later episode now that my house is done, and we can review that, because there wasn't anything super exciting about the rough inside. I do want to spend a minute, though, on this water softener system. I published this video, and I got to tell you, it's been a really controversial video. Nuvo H2O is they call it a water softener. Many of the comments said it shouldn't be called a water softener. It should be called a water conditioner because it doesn't use salt. It's a citric acid based system which prevents scale formation. And I've had it in my house for 2 years, and I have extremely hard water in the city of Austin where I'm located. And I've had zero problems with any scale formation on any one of my fixtures, whereas my old house had serious problems with that. And I'm literally across the street, so I know the water supply is the exact same main that I was on before. I changed my cartridge probably longer than I should have. You're supposed to change these at about 6 months. I bet I've gone more like 9 months. But what's cool about the system is even if you had built up some scale, it will pull that scale off by putting that new cartridge on. And it's a filtration and a conditioning system. So what you're seeing on this video here is there's also a nice filter there, which saved my bacon, because when my landscapers came at the end of the project, they actually accidentally cut my line into the house, and I got a bunch of dirt in the line, and that filter caught all that dirt before it got into my system. And it was one of those like, oh my gosh, I'm so thankful I had this pre-filter on my house, which saved me getting dirt in every one of my fixtures and having to take every shower head, every aerator, everything off my house, probably more than once, to get all the dirt and grit out of the system. In the end, it ended up in that cartridge. But this is a maintenance item. You do need to switch that filter on the right there that you're seeing behind me, that Nuvo H2O cartridge, on a 6 month or so basis. And I forget the exact cost. They're a couple $100 on an annual basis. But not having to lug salt, and for me not having that slimy feeling like you get with a salt-based system, also no waste. I don't have to have a drain for this at all. It's a really nice system. Let's check out a quick portion of the video here.
Traditional softeners, we've seen them all. They have a big tank. You got to lug a salt bag from the grocery store and fill that up. They do a brine flush on a nightly basis, and you have to have a drain system for them. You have to have electricity. They're pretty big. You need a pretty decent amount of space in your garage for them. But what we're talking about today is a totally different system. This Nuvo H2O system, installed right here, this is my main water line into my house. So it's basically the first thing right after my shutoff valve. This system has 2 cartridges. And one of these cartridges right here is what's actually doing the work to prevent that scale. Some people call it a softener, some people call it a conditioner. It doesn't really matter. What matters is this is going to prevent the scale buildup in your system. And it's doing it in a different way. Instead of that salt that a traditional system is using, this is using citrus in there. Now here's how it works. The citric compound binds to the hard minerals, so the minerals can't bind to your pipes and surfaces. This system will prevent the scale from happening in your system and will actually remove existing scale if you were to install this into a house that's not brand new like my house is. A couple other benefits. It tastes great. I have no difference in taste from the hard water that I had before. I like that taste. And the other big deal is you can water your houseplants with this. A traditional softener system, you don't want that salt, that sodium in your water. It's bad for your houseplants. This one, no big deal. Now you do need to replace these cartridges on a regular basis. About every 6 months you're going to want to replace both your filter and your cartridge. I've got a bigger house. I have 4 kids. I have some teenagers that take long showers. I might actually replace mine slightly earlier at like 5 months. But these are pretty reasonable in cost, 135-ish bucks for a replacement cartridge here. So we're not talking about a lot of money. And the filter system is going to unscrew, and we're going to drop a new filter in, and we're going to drop a new softener cartridge in. So pretty straightforward. Nuvo also makes 2 smaller cartridge systems that are more like a point of use. So for instance, I mentioned at my old house, my tankless water heater scaled up on me. Had I known, I could have bought one of these. This is a water heater system that's a small one intended just for the water that's going into the water heater to prevent that scale. That's a big deal. That could really make a difference on both a tankless or a tanked unit. And they also make a dishwasher specific system. This would be mounted probably underneath your kitchen sink, and the line going to your dishwasher would be plumbed here first. It would really extend the life of your dishwasher. And this would be an easy way to get that benefit of just a specific spot if you couldn't retrofit this for your whole house.
Okay, before we wrap up, I didn't actually shoot much video on this, but that water heater tank that you're seeing in the background, that's kind of a big tan tank. That's a SAN CO2 heat pump water heater system. It's really a top-of-the-line system. It's also a bit of a top-of-the-line price. What it is a split. It's a split system. So that tank that's behind me is a stainless steel holding tank. It's basically a big dumb tank. Not dumb. It's stainless, which is pretty awesome. It'll never rust. But all it's doing is holding the hot water. And then there's 2 1/2-inch Uponor PEX lines that run from that tank outdoors that are basically taking water from the cold part of the tank, which would be, let's see, the bottom of the tank, taking it out to the outdoor unit, which is a heat pump, which, oh, by the way, is powered not with traditional Freon, but with CO2 as the refrigerant. That's pretty cool. And it's taking the heat out of the outdoor air, dumping into that water, and then using a small pump to bring it to the storage tank and dropping it in that storage tank, where then my house is pulling out of that storage tank. I've had that system now for 2 years, and I was worried that I might have to turn it up. And one of the things I liked about the system was that you could go up to, I think, 160 degrees. Don't quote me on that, but I know it's more than 140, which a lot of systems are limited by. I've got mine set at like 125. I've got 4 kids. 3 of the 4 of them are teenagers, and my wife takes a solid shower every night. I don't want to throw her under the bus and tell you how long, but I've yet to run out of hot water in this house. I mean, it's been fantastic. I've absolutely loved it. It's been as good as my old house that had a Rinnai tankless, which you really never run out of hot water with those. But very efficient, and also all electric. I ended up going all electric on my house. Stay tuned for kind of review of all electric and a couple things that I might do differently in a future episode. We've got episode 4 coming up, which is windows, roofing, and siding. Another long episode on that one. But guys, I really appreciate your support. Thanks for taking a relook back at my real rebuild. I mean, an amazing house, really one of the best houses I've ever built, and has absolutely been a joy for my family and I to live in. So guys, thank you for your support. We'll see you next time on The Build Show.